Yes. Yes, the next topic is individual metals, that is the extraction of the metals. Next one is extraction of iron. Now, what are the important sources of the iron? That I mentioned, the important minerals and ores and principal ores of the iron are hematite, magnetite, siderite and limonite. Whereas hematite, it is the principal ore of the iron. Hematite. Its chemical composition is Fe2O3, and magnetite, it is often called as a ferroferric oxide, that is Fe3O4. It is a mixture of ferrous oxide and ferric oxide. It is a mixture of ferrous oxide and ferric oxide. Often it is called as a ferroferric oxide. And one more is siderite. It is a carbonate ore, ferric carbonate. Then limonite. Hydrated compound, 2Fe2O3 and 3H2O. This is a hydrated metallic oxide of the iron. In your entrance exam, they will ask, and one more is iron pyrites. FeS2, iron pyrite, that is FeS2. These are the important minerals and ores of the iron. Among these, it is called as a principal ore of the iron. Principal ore of the iron. In your entrance exam, usually they will ask match the following type of questions in NEET. In column 1 or column A, they will give this type of the important minerals or ore. Chemical composition of the formulas will be given in column B. You have to match. Or they may ask which one of the following is an oxide ore, which one of the following is a sulfide ore, which one of the following is a carbonate ore, which one of the following is a hydrated ore, like that. Therefore, in hematite, it is an oxide ore of the iron. Magnetite is also an oxide ore of the iron. Siderite is the carbonate ore, or simply it is called as a mineral. And limonite is the hydrated oxide, whereas iron pyrite is a sulfide form of iron. It is not used in the extraction of the iron, rather than it is used in the production of the sulfur dioxide by means of the chamber process. Because upon oxidation reaction or roasting, it gives sulfur dioxide. Therefore, sulfur dioxide after purification and followed by means of oxidation reaction, then it is used in the manufacture of the sulfuric acid, the raw material for the manufacture of the sulfuric acid, not in the extraction of the iron. Is it clear? These are the important minerals and ores of the iron. Therefore, hematite, magnetite, siderite, limonite, iron pyrite. Usually in a pyrite, if it is used as a suffix, that always remember it is a sulfide form of the mineral. Whereas a pyrite, chalcopyrite, it is a sulfide mineral. Whereas whenever it ends with the suffix that is a pyrite, make ensure that it contains a sulfur as one of the component. Is it clear? Now, what are the important steps involved in the extraction of the metals? Important steps in the extraction of the metals that I mentioned already. Important steps. That is the crushing, concentration, roasting and smelting and refining. Important step. Hematite is the principal ore of iron. Hematite is a principal ore of iron. Principal ore of iron. Its chemical composition is Fe2O3. Chemical composition is Fe2O3. Chemical composition is Fe2O3. Is it clear? Then what are the important steps? Steps involved in the metallurgy. First one, crushing operation. First one is crushing operation. Second one, concentration. Crushing and concentration. Third one, calcination. Calcination. Fourth one is smelting. In smelting, here we are using carbon reduction method. Carbon reduction method. Carbon reduction method. Here we are not using the refining stage because the purified iron has no mechanical applications. Because it is very soft, it is very malleable one. In the presence of the impurities, it will be hardened. Therefore, we can improve the mechanical properties. Now, why it is necessary to prepare alloys? What about the important properties of the alloys rather than that of the pure metals? See, we are extracting the metals in their pure form in order to avoid rusting or corrosion reaction. Finally, if it desired, then we can convert into the alloy form of the metal. What is the objective of the formation of an alloy? Reason, we can improve the properties of the metals, especially the properties of the metals are mechanical property, electrical property, electronic property and shining property. These are the very important properties, commercial properties of the metals. In some cases, for example, gold or silver, when they are obtained in 100% pure form, they are very soft materials. Like that of your rubber, we can bend. Therefore, in such cases, we cannot expect the mechanical properties of the materials. Therefore, by the addition of the small quantity of the impurities, we can harden the metal. Therefore, the hardened metal, which is very stiff, they have mechanical applications. Whereas inert hardened, that is the mechanical property. Whereas in case of iron also, you know that the malleable iron, that is soft iron, very purest form of the iron is malleable iron. You know that the three different forms of the iron, pig iron, where is the cast iron, where the impure form of the iron, pig iron is the impure form of the iron, which contains the highest percentage of the carbon. Whereas the steel that contains intermediate component, the carbon. Whereas a malleable iron, very soft iron, which contains very smaller concentration of the carbon, then it has no mechanical applications. Therefore, in your entrance exam, they may ask questions like this: which of the following is the purest form of the iron? Your answer is malleable iron. Which one of the following is where is the impure form of the iron? That is a pig iron is the impure form of the iron. Whereas in case of the steel, we have different grades of the steel. Whereas carbon is one of the important component that decides the quality of the steel. In addition to this mild steel, hard steels like that. Again, by the addition of some of the transition metals, we can improve the applications of the materials. Is it clear? We can afterwards we can discuss one by one. Therefore, what are the important stages that are involved in the extraction of the metals? There is a crushing, concentration, either roasting or calcination. Here it is a calcination. Last one is a smelting. Refining stages are not here. Therefore, ore is crushed in jack crushers and powdered in ball mills. Crushing means size reduction process that already mentioned. Crushing here refers to size reduction process. Huge lumps of the hematite. Huge lumps of the hematite, they are not used in our devices or the furnaces. Therefore, they can be converted into small pieces. By means of the crushers, by means of the jack crushers, we can cut into the small pieces. And after hammering, we can convert into powder. There is a jack crushers, and it is powdered in ball mills. Finally, it is sieved by using meshes. In order to obtain the smaller particles. Is it clear? Hematite ore is crushed in jack crushers and powdered in ball mills, and it is sieved to get the required size particles by using meshes. What about the concentration? What is the objective of our concentration process? In order to remove the impurities as much as possible. Whereas the 100% removal of the impurities is not there in a single stage. Always the impurities are associated that can be removed in the next operation. Here usually contains the lighter components of the earth, therefore can be removed by means of levitation process or gravity separation process or washing process. Therefore, by means of gravity separation process, we can remove gravity separation, that already explained. Gravity separation process. There is a concentration by means of the gravity separation process. This is made by means of washing, washing in a current of water, washing in a current of water. Now, lighter components of the earth are removed. Lighter components of the earth are removed by means of this gravity separation technique. Is it clear? Next one is calcination. Here the concentrated hematite is heated in a limited supply of air or oxygen. Then what happens during this process? It undergoes calcination. Here, what will be calcination? The process of heating the concentrated ore in the limited supply of the oxygen or air, or no supply of the oxygen or air, is called calcination process. During roasting, we are heating the concentrated ore at high temperature but below the fusion point of the metal or the metallic compound in a current of excess quantity of air or oxygen. Now, during this process, in calcination and roasting process, we are heating the concentrated ore below the fusion point of the wanted metal or that of the metallic compound. If it is heated above the fusion point, then what happens? In the molten state of the metal, when it is heated above the fusion point, then metal is converted into the molten metal. Therefore, the molten metal or the fused metal, they have ability to dissolve the impurities present. Therefore, in such cases, impure metals are obtained. Therefore, better to avoid the high temperature. Within the bracket, you have to specify below the fusion point of the metal or below the melting point of the metal. Is it clear? Yes. Now, in the calcination process, what do you mean by calcination process? Calcination, during this process, any ferrous oxide, if any present, then undergoes oxidation reaction, therefore it is converted into ferric oxide. If any small concentration of the ferrous oxide that may be present along with that of the principal ore, then it is oxidized to ferric oxide. That is the objective of the calcination process. Here the moisture is removed, moisture volatilizes. If any arsenic or antimony impurities are present, then they are oxidized to the respective stable oxides, non-metallic oxides. Arsenic is converted to arsenic trioxide, antimony is converted to antimony trioxide. Therefore, the ore becomes more porous in nature. Here the moisture expels during the roasting or calcination process, and volatile impurities are oxidized and expelled, and ore becomes more porous in nature and is readily used for the next operation. The last one is smelting operation. This is very important. Smelting operation is very important. Now we will discuss about very important in your board exam. Very important question. Write the various chemical reactions that occurs in the reduction of the hematite in blast furnace or smelting operation. Smelting here corresponds to carbon reduction method. Carbon reduction method. It consists of blast furnace. Yes. This is about the extraction of the iron by using carbon reduction method by means of Bessemerization process or Bessemer converter. It is a converter. It is a converter. Now the converter is a device used to convert the metallic oxide into the metal by means of various chemical changes. Now this is Bessemer converter. It is a tall cylindrical tower. Try to understand. It is a tall cylindrical tower. The diameter that gradually increases from top to bottom, and the widest part of the furnace, that is called as a Bosch's region. The widest part of the furnace is called as a Bosch's region. Is it clear? This is what the designing of the converter. It is around 25 meters long. Just imagine 25 meters long in open air or open atmosphere. Whereas the diameter that highest in the Bosch's region, below the Bosch's region, the diameter gradually decreases. Below the Bosch's region, the diameter gradually decreases, and it is provided the hearth region at the bottom of the furnace. And it is provided the two exit holes. One is for molten metal and one is for molten slag. This is for molten slag. This is for molten slag. The upper one is molten metal. The upper one is molten metal. The upper one is molten metal. The hearth region is provided the two tap holes, exit holes. The bottom exit hole for removal of the molten slag, and the top exit hole for the removal of the molten metal. And the furnace has provided the one exit hole at the top of the furnace. This is for the removal of the flue gases. This is for the removal of the flue gases. Flue gases means waste gases. Waste gases like that of the carbon monoxide, carbon dioxide, sulfur dioxide, etc. This can be removed. Exit gases in the sense either the removal of the carbon monoxide, or for the removal of the carbon dioxide, or for the removal of the sulfur dioxide. These are considered as waste gases, exit gases, flue gases. Now this is about the construction of the converter. Construction of the converter, Bessemer converter. Again, once again, you have to remind, it consists of a tall cylindrical tower. The diameter of the tower that gradually increases from top to bottom, and it is provided the widest part. That widest part is called Bosch's region. Below the Bosch's region, we have hearth region. The hearth region is provided the two tap holes or exit holes. One is for the removal of the molten metal, and one is for the removal of the molten slag. Make ensure that the molten metal is at the bottom and molten slag is just above the molten. That is below the Bosch's, that is a Bosch's region, and above that of the molten slag. This is upper. This implies that molten metal is lighter than molten slag. Sorry, this is for molten slag. This is for the removal of the molten slag, and this is for the removal of the molten metal. Because the slag is lighter compared to that of the molten metal. This is for the removal of the molten metal. Upper layer is for the slag layer that protects the molten metal from atmospheric oxidation reaction. Now very important, the furnace is provided with one water cooled pipe in order to avoid loss of heat to radiation. The inner surface of the furnace is layered with the fire resistant bricks. Because the temperature inside the furnace is very high, therefore if it is made up of the steel, then it will undergo chemical interactions at high temperature. Inside the furnace, it is layered with fire resisting bricks. What do you mean by fire resisting bricks? Which have ability to withstand high temperature, which has ability to retain the high temperature. Because the chemical reactions that occurs in the furnace, it is around 2070 Kelvin temperature. That is very high temperature, more than 1500, 1600, 1700 degrees Celsius temperature. Therefore, without the protection materials, such type of the materials, when directly used the furnaces for combustion chemical reactions, you know the combustion chemical reactions that provides more amount of the energy. Therefore, at this high temperature, the possibility of distortion, that's of the material. That is the reason why it is covered inside by means of fire resisting bricks or temperature resisting bricks. This is often called as they have ability to withstand high temperature without undergoes thermal cracking, without undergoes deformation, without undergoes chemical change. Such type of the metals are incorporated inside the furnace. Just above the furnace, if suppose we are using water cooled pipes, we are circulating cold water continuously, because whenever the high temperature is retained inside the furnace, there is a loss of heat due to radiation. In order to avoid the loss of heat due to radiation, we are circulating cold water around the surface of the furnace. That is about the objective of why we are passing cold water and what is the importance of the fire resisting bricks. Is it clear? Fine. Now come to the process. What about the chemical process that is involved? The chemical process that is involved in the furnace. Chemical process involved in the furnace. It consists of different zones. In your entrance exam, they will ask the temperatures. Therefore, zone of complete combustion. Zone of complete combustion. Zone of complete combustion. Now, this portion is called as a zone of complete combustion. This portion is called as a zone of complete combustion. Because the raw material, what about the raw material used? Raw material used is calcined hematite. Calcined hematite. Calcined hematite plus limestone. Calcined hematite plus limestone plus desulfurized coke. Desulfurized coke. Raw materials required for the extraction procedure are, whereas calcined hematite and limestone and desulfurized coke in the ratio of 8:1:4. In the ratio of 8:1:4. Means for every 8 ratio of the calcined hematite mixed with 1 ratio of the limestone and 4 ratio of the desulfurized coke. Desulfurized coke. Now what is the role of the coke and limestone in the metallurgy of iron? What about the role of limestone? Role of limestone and coke. Role of limestone and coke in the metallurgy of iron. Now why it is necessary to use desulfurized coke? What is the relationship between coke and desulfurized coke? Whereas a coke that is obtained by means of various natural processes, by means of the plants. Usually plants contain sulfur, therefore sulfur is associated with that of the coke always. When directly the coke is used during combustion chemical reaction, the important components of the coke are carbon that undergoes oxidation reaction. Fine. Whereas next sulfur, suppose associated with the coke, then it undergoes oxidation reaction during combustion. It also gives rise to sulfur dioxide. Whenever sulfur dioxide gas is produced inside the furnace and it dissolves in the molten metal at high temperature, therefore the quality of the metal that will be destroyed. That is why before using this coke, it is subjected to calcination process, that is in the absence limited supply of the air or oxygen, and it is heated at very high temperature below the melting point. Then sulfur components, if any, present along with that of the coke, then they undergoes oxidation reaction below the fusion point of the metal. Then sulfur dioxide is expelled, or coke becomes more porous in nature. That porous coke is called as a desulfurized coke. Is it clear? Now for every 8 kg of this calcined hematite, use 1 kg of the limestone and 4 kg of the desulfurized coke. Now this coke acts as a reducing agent. Limestone acts as a basic flux in the metallurgy of iron. Limestone, basic flux. Limestone basic flux, and coke is a reducing agent. Coke is a reducing agent. Very important. Here coke directly not reduces ferric oxide to the iron. Only at higher temperature of the furnace, ferric oxide is directly reduced by the carbon, elemental carbon. But at low temperature of the furnace, means above the Bosch's reason, the coke undergoes oxidation reaction in the blast furnace. Use carbon monoxide first, which further undergoes oxidation reaction to give carbon dioxide. Or it undergoes carbon dioxide followed by reduction reaction with incoming coke, then it gives rise to the carbon monoxide. Carbon monoxide is a reducing agent at lower temperature of the furnace, and carbon is a reducing agent at higher temperature of the furnace. Is it clear? Fine. Now this is called as a cup and cone arrangement. Cup and cone arrangement. Now we can lift the cup and cone arrangement by means of mechanical machines, and we can introduce this calcined hematite and limestone and desulfurized coke. This mixture is fed into the blast furnace. This mixture is fed into the blast furnace by means of cup and cone arrangement. This is called as a cup and cone arrangement. Cup and cone arrangement. Cup and cone arrangement. Cup and cone arrangement. Is it clear? Now At the gaseous region, we are passing air. We are passing air or oxygen. We are passing air or oxygen by means of water cooled lamps. These are called as tuyeres. These are called as water cooled lances near the gaseous region. What is the usage of this water cooled lance or tuyeres? In order to supply the air into the furnace. Now what happens? As the charge, this is considered as a charge, and the charge that descends into the blast furnace by means of cup and cone arrangement, then oxygen is made to pass through the gaseous region at the middle of the furnace. Then what happens? As the air that ascends and the charge that descends, this is air and this is charge, then they will meet somewhere. Here we are passing charge, here we are passing air into the furnace, somewhere they meet one another. At this stage, the carbon is oxidized to carbon dioxide. Carbon is oxidized to carbon dioxide. Now high temperature will be produced. That zone is called as a combustion zone. C plus O2, that gives rise to CO2. Therefore delta H of the process is negative because that is an exothermic chemical reaction. Is it clear? Therefore large quantity of the heat is produced at this region. This is an exothermic reaction. Conversion of carbon to carbon dioxide is an exothermic reaction. Therefore more quantity of the heat energy will be liberated during this process. That is why the gaseous region that acquires higher temperature, that is prevailing around 2070 Kelvin temperature. Is it clear? Fine. As the carbon dioxide that ascends from the gaseous region to the top region, then it combines with the incoming coke, then carbon dioxide is reduced to carbon monoxide. Carbon dioxide is reduced to carbon monoxide. Carbon dioxide is reduced to carbon monoxide. Now this process is endothermic process. This process is endothermic process. That is the reason why whenever carbon dioxide gas that moves from gaseous region to the top region, then reduction reaction will occur. It gives more and more amount of the carbon monoxide. The conversion of carbon dioxide to the carbon monoxide is endothermic process. Oxidation reaction is an exothermic process. Reduction reaction is an endothermic process. Endothermic process means it utilizes the small quantity of the energy. Therefore, the temperature falls gradually from gaseous region to the top region. Therefore, the furnace will acquire least temperature at the top and very high temperature at the bottom. Therefore, whenever the furnace is in working condition, then minimum temperature at the top of the furnace and maximum temperature at the gaseous region of the furnace. Therefore, we have various temperature zones. Various temperature zones. Is it clear? Now, somewhere the temperature, here we have 1000 degrees Celsius. What about the zone of complete combustion? Here carbon is converted into carbon dioxide. Here the temperature availing, that is 2170 Kelvin temperature. Very high temperature is attained by means of the furnace. That zone is called complete combustion zone. What about the chemical reaction that will occur at complete combustion zone? Carbon which is present in the charge, desulfurized coke that contains carbon that present in the charge, that is converted into carbon dioxide. Therefore, more quantity of the heat energy will be released and the temperature attained by this zone is 2170 Kelvin. That zone is called as a complete combustion zone. Is it clear? Now, why that furnace will occur low temperature at the top? Because of reduction reaction of the carbon dioxide to the carbon monoxide. Now, That is about the reactions that occurs at the zone of complete combustion. Zone of complete combustion. Zone of complete combustion. Zone of flux formation. Zone of flux formation. Now here calcium carbonate, this is called as a limestone. This is called as a limestone. That is used in the charge. That is ultimate limestone. What is the role of the limestone? Calcium carbonate alone does not act as a flux, because calcium carbonate that decomposes at high temperature, then it gives rise to calcium oxide and carbon dioxide. Again, this calcium oxide is called as a flux. Calcium oxide. This is often called as a climb. This calcium oxide is a flux during the metallurgy of iron. Actually, limestone not directly acts as a flux, because it undergoes thermal decomposition at higher temperature of the furnace, around 1000 degrees Celsius temperature, 800 to 1000 degrees Celsius temperature. That is around 1270 Kelvin. 1000 Kelvin. 1000 Kelvin to 1270 Kelvin. That is from 800 degrees Celsius to 1000 degrees Celsius temperature. Limestone decomposes to give off carbon dioxide. Then it gives calcium oxide. That calcium oxide acts as a flux. Therefore, this is called as a flux formation zone. Flux formation zone. Next one more is that is called as a zone of slag formation or slag formation zone. Slag formation. Now this is, what is slag? Where is flux plus gang or impurity that gives rise to slag. Flux plus gang that gives rise to slag. Flux plus gang that gives rise to slag. Here calcium oxide is a flux and silicon dioxide is an impurity, or sand is an impurity associated with that of the hematite. Then it gives rise to calcium silicate slag. Calcium silicate, this is slag. Now in the iron metallurgy, calcium silicate slag. Very important, they ask one more question. Name the slag that formed during the metallurgy of the iron. Calcium silicate is the slag obtained during the metallurgy of the iron. Metallurgy of the iron. Just above 1270, that is around 1500 degrees Celsius temperature. Then flux and this calcium oxide, that is the flux that fuses with that of the sand, then it gives rise to the calcium silicate slag. Now that calcium silicate slag that flows down the furnace and it is collected above the molten surface of the metal. Above the molten surface of the metal. Is it clear? That is a slag formation. That is around 1270 Kelvin. Around 1270 Kelvin. 1270 Kelvin. 1270 Kelvin. Now this fuses to give the slag. In some cases it may be 1000 degrees Celsius temperature. Where just above 1270 Kelvin, the flux combines with the slag that gives rise to calcium silicate. Therefore, in your entrance exam, they ask the questions like this. Match the following type questions: zone of complete combustion, zone of flux formation, zone of slag formation. Keep it in your mind. Zone of complete combustion or complete combustion zone, complete combustion zone. Flux formation zone, around 1000 Kelvin. Slag formation zone, (1270 Kelvin). Slag formation zone. Very important. Next one is reduction zone. Reduction zone. Now, the reduction zone, that is in two different phases: at lower temperature of the furnace and at higher temperature of the furnace. At lower temperature of the furnace, at lower temperature of the furnace, carbon monoxide is a reducing agent. Carbon monoxide is reducing agent. At higher temperature of the furnace, at higher temperature of the furnace, coke is a reducing agent. Coke is a reducing agent. At 1070 Kelvin temperature, at 1070 Kelvin temperature, at 1070 Kelvin temperature, at 1070 Kelvin temperature, that is lower temperature of the furnace. Here ferric oxide combines with carbon monoxide, then it gives rise to iron and carbon dioxide. Here carbon monoxide is oxidized to carbon dioxide, carbon monoxide is oxidized to carbon dioxide, and ferric oxide is reduced to iron. Hematite is reduced to iron, carbon monoxide is oxidized to carbon dioxide. Is it clear? This is 3CO, that is 3CO2 and 2Fe. Now this is about the reduction zone. But at higher temperature of the furnace, near the Bosch's region, it is directly reduced by means of the coke. It is directly reduced by means of the coke. This is only in Bosch's region. At higher temperature of the furnace, ferric oxide is directly reduced by coke, then it gives rise to iron and carbon